Now see a relation between alpha and beta. Alpha is the coefficient of linear expansion, beta is the coefficient of area expansion. So to show the relation between alpha and beta, just take an example of any square plate. Suppose you have taken example of a square plate whose length or the side is L. When it is heated, its length increases by delta L and area increases by delta A and temperature increases by delta T. So, new length will become on heating by this one, on increasing the temperature by this amount, new length is equal to L plus delta L and new area is A plus delta A. Now, we can write here A plus delta A is equal to L plus delta L whole square. Now, in place of delta A we can write here, we have already done like this formula, beta is equal to delta A upon A delta T. So, here we can write delta A is equal to beta A delta T. So, A plus beta A delta T is equal to L plus L alpha delta T, that is a whole square. Now, here we can take common A. So, here A into 1 plus beta delta T is equal to L square, that is coming L I am taking common here. So, L is square outside 1 plus, here we can take alpha delta T. Now, that is a whole square here. We can apply here the binomial theorem and we can get, when we apply here the binomial theorem, so we can write this as this and this will get cancelled because A is equal to L square. So, you will be getting 1 plus beta delta T is equal to 1 plus twice of alpha delta T, cancel, and this also get cancelled. You will be getting beta is equal to twice of alpha or alpha is equal to beta by 2. So, this is the relation between alpha and beta. Now, see a relation between alpha and gamma. So, here the gamma is a volume, a coefficient of volume expansion. So, to show the relation between alpha and gamma, you consider a cube of length L. So, you have taken a cube whose length is L and original volume is V. When you increase temperature by delta T here, so the length will become L plus delta L and volume will become V plus delta V by increasing the temperature by this. So, now we can write here V plus delta V is equal to L plus delta L whole cube. We can take common here. So, V plus delta V is equal to, here we can take L cube common. So, 1 plus here delta L by L cube. Now, in this case you have to take just common V here also and put the value of delta V. So, we can write here delta V is equal to V into gamma delta T. Similarly, delta L is equal to, you can write here alpha L delta T. So, now we can write here V, if you have taken common, 1 plus, in place of this delta V, here we can write delta V upon V is equal to L cube 1 plus delta L upon L here whole cube. This and this will get cancelled, and now we can write here 1 plus, in place of delta V we can write here 1 plus gamma delta T is equal to 1 plus delta L upon L can be written here alpha delta T, but here we can use binomial. So, we can write 3. Now, this 1 will get cancelled. So, gamma delta T is equal to thrice of alpha delta T. I have used here binomial, this and this will get cancelled. So, you will be getting here gamma is equal to 3 alpha. So, now you have got here in this case gamma is equal to 3 alpha. So, we can write here alpha is equal to gamma by 3. So, the relation can be written alpha is equal to beta by 2 is equal to gamma by 3. So, this is the relation between alpha, beta and gamma.